Imagine trying to give 5 million business users instant access to their company's knowledge across Google Drive, OneDrive, Box, and other platforms, while making absolutely sure that nobody sees a document they shouldn't. Now, this is the challenge that OpenAI faced while building ChatGPT Connectors. We're talking about 37 billion documents, each with its own fine-grained access controls. Permissions that change in real time as people move between teams, projects, roles, and so on. So in this video, we're going to explore why traditional authorization approaches struggled for this kind of use case and how OpenAI solved this at scale. And most importantly, how you can apply the same ideas to your AI pipelines. Let's dive in. Connectors in ChatGPT is a feature that allows you to integrate internal knowledge sources and third-party applications directly into ChatGPT. But the challenge here is ensuring that when an employee asks questions, they only see documents they're authorized to access. And now this is not suited for a traditional authorization model such as role-based access control or RBAC. And this is because permissions aren't static. They change constantly when someone joins a project or leaves a team. And don't even consider building a custom authorization solution for a use case like this. It can get really complicated at this scale. So what kind of system can handle something like this? When you break down the requirements, low latency, scale, availability, etc., this is exactly the kind of challenge Google solved internally with Zanzibar, their global authorization system across apps such as Docs, Gmail, YouTube, and so on. And Zanzibar introduced a few key ideas, such as a centralized permissions database that all applications can query in real time, and fine-grained relationship-based access control or RBAC instead of RBAC, and also horizontal scale so that it can handle millions of requests per second across billions of objects, all with low latency. That's why a Zanzibar-style architecture is such a good fit here. Instead of every connector reinventing authorization logic, OpenAI has one consistent high-scale service that all these connectors trust. And what OpenAI used is SpiceDB, the most advanced open source implementation of Zanzibar. It gives you the Zanzibar model with a flexible schema language and the ability to model complex real-world permission systems. And this gave OpenAI an architecture where documents can flow in from different sources, but permissions are stored in a central system. And every query against ChatGPT first checks, does this user have access to this document right now? And that's the key idea. Separating authorization into its own scalable system so the application can focus on serving the best result. So what does this look like? Well, at a very high level, this is the pattern you can follow. You first define a permission schema, which defines the type of objects found and how these objects relate to one another and the permissions that can be computed off of those relations. In this case, it's about users and documents and the relationship and permissions between them. You store relationships between specific users and specific documents, and then at query time, the system first checks with the authorization service, in this case SpiceDB, before giving the result to the user. So in a production system, what does this authorization check look like? Well, there are two architectural approaches you can take for this authorization check, a pre-filter and a post-filter approach. Let's talk about the post-filter authorization approach. Here, the system retrieves candidate documents from the vector database without applying authorization filters upfront. Then, the user's access to each document retrieved is checked against SpiceDB using metadata that is also embedded into the vector database. And only then, if the user has permissions to access this document, is it then passed to the LLM. Now, this method is efficient if you have a high positive hit rate of results from your vector database. There is also the pre-filter authorization approach. In this model, the user's query is first embedded and then filtered through the authorization system before it even touches the vector database. This means only the documents that the user is allowed to see is retrieved as context. This method is great, especially when you have a large number of documents and a low positive hit rate. What matters most though is that the authorization happens somewhere in the flow. You have to ensure that your user only sees what they're allowed to see. Check out the video linked in the description for a code run through of this exact use case. So here's the takeaway. Like OpenAI with ChatGPT connectors, the same principle of fine-grained authorization applies, but you need the infrastructure that can handle the scale of billions of documents and millions of users with real-time updates. And that's where AuthZed Dedicated comes in. The problem of who can see what doesn't go away with AI. In fact, it only gets harder as your system grows. By separating authorization from application logic and making it scalable, you can build AI systems that are not only powerful, but also secure and trustworthy. Thanks for watching, and if you want to try this for yourself, check out the notebook linked in the description. See you in the next one.